Good morning, my name is Edward Wasudun. This morning we are going to be doing an ordinary least square estimation, but we are going to adopt a study approach. Study approach in the sense that we are going to look at the impact of stock markets, variables on economic growth in Nigeria. And to have that done, the first thing to do is to visualize the stock market variables I actually want to use for this estimation. We have the stock market variable starting from 1985 to 2021. This particular data was taken or collected from the Central Bank Statistical Bulletin. So in this data set, we will be using our GDP as a proxy for economic growth, while market capitalization, interest rates, a number of deals in the stock market, and the value of transactions in the stock market will serve as the explanatory variables in the estimation. So basically, the way I load my data most of the time, I will highlight all of these variables starting from the first one, including the year. I open my EViews portal and I paste them. I right click, I paste them in my EViews portal. Once they are pasted in my EViews portal, then that means that I've loaded the particular variable in the EViews worksheet. Recall that my start year is 1985. That's my start year, 1985, and I click finish, click yes. So this is my EViews worksheet. This is my EViews worksheet. So recall that in my previous video, I told you that for you to do an OLX, it is assumed that all the variables under consideration are all integrated at level or order 0. When a variable is integrated as order 0, it means that those particular variables were reverting to their mean, or that there is no unit truth problem in those variables. And in a situation where your variables will not have a unit truth problem, then the best method or the best approach to adopt is the long run approach, which is the OLX approach. To actually estimate the OLX, given the assumption or presumption that all the variables in today's class became stationary at level or they reverted to their mean, then we are going to proceed to perform an OLX expressly. To do an OLX, we also need to interpret it in line with the ceteris paribus assumptions or interpretation. So the first thing to do, if you assume that your variables were stationary at level, you go to quick. Once you hit quick, you go to equation estimate. Then this particular equation estimation box will pop up where you see specification, option, and the estimation setting. The estimation setting will remain. Then the sample size remain 1985 to when you actually wanted it. But given the fact that the sample size is above what I wanted, so I will need to go to proc to adjust the sample size. Go to proc, go to structural resize current page, then I come over here, adjust the sample size to actually what I wanted, 2021, 2000, I need 2020. I want to stop at 2020. So I click OK. I click OK. My sample size has been adjusted from what it were before to 36 years observation. I'm doing a study from 1985 to 2020. That is how I want it. Then going back to my previous page, go to quick, go to equation estimates. Then once you are in equation estimation box, the first thing you have to ask yourself is, one, the variables you are working with, are they loggable variables, or they are variables that you allow in their natural form? If they are not variables that will be logged, then at that level you have to allow them. Recall in my previous video I told you that Whenever time you find yourself in this particular situation, the first thing you ask yourself, these variables I'm using, are they values, are they numbers, are they tone? Whenever time you come across tone, values and numbers, you have to log them. Then when you come across percentage and ratios, you don't log them. The reason why we actually log values, numbers and tone is to make them to be in par with the percentages or the ratios. Or whenever time you find yourself that all of them need to be logged, then you log all of them. If all of them will not be logged, you log the ones that are supposed to be logged to make them to be in par with whatever thing you are doing. Then at this specification box, we have the option. In this option box, you don't have any business here already. Our estimation procedure is the ordinary least square. We are not using Hover White, or we are not using Noah West estimation. Then we also have other weighted average that at this moment is not necessary. So while you are actually looking at it, the next thing you are supposed to do is to estimate your equation. Recall that we are looking at how market capitalization or how the stock market variables affect economic growth. And economic growth in this particular study, we are using real GDP as a proxy for economic growth. So the first thing to be done is to type in the log of real GDP. The log of real GDP. But I like using capital letter because when you use capital letter, the result will be actually fine. Log of real GDP. Log of real GDP taken as the dependent variable. You give a space. The next thing you will do is to actually look at the other variables we are considering, the capital market variables, the value of share, the number of transactions. They are all values. So since they are all values, you log all of them. Log MCAP, log we now have log VTran, log VTrans. We have log VTrans. Then we also have interest rate in that model. We now give a space and type in interest rate. Interest rate will not be logged. Then we click OK. Once you click OK, you are going to be exposed to something that looks like this. This is your OLS result. So the next thing we'll do is to copy this OLS result neatly and go to a Microsoft Word where it will actually be interpreted. But one thing that should also be known in OLS result is that there are major parameters, major indices that we actually need to know, we actually need to see, we actually need to observe a OLS before we will say that our OLS result is okay. So given the fact that we have looked at the variables under consideration, the one we have used, and come up with this result, I will now go to Microsoft Word where the results will be pasted and interpretation will actually be done. But before interpreting your OLS result, you should actually look out for certain parameters on certain items, because normally the first condition is that we must ensure that there is no issue of first order autocorrelation in the equation estimate. Recall when I taught you about the basic assumption of the classical least square, I told you that those assumptions must be upheld because the post-estimation test requires that one, there should not be any issue relating to first order autocorrelation in your OLS estimation. And secondly, your W-Watson statistics should be able to explain that. If your W-Watson statistics is okay, then that means that, or within the normal bound, that means that there is no issue relating to first order autocorrelation. And thirdly, majority of your coefficient actually need to be statistically significant. So let's look at it again from the beginning. We have what we call the dependent variable, which is the log of ROGDP as shown here, the dependent variable. We use the least square estimation, that is the most appropriate OLS estimation techniques. This estimation was done today, the 17th day of June 2023 at 13:46. The sample size we use is the 1985 to 2020. We had 36 observations and we used the 3 explanatory variables. this region where we have the variables, we have the coefficient, we have the standard error, we have the t-statistics, and we have the probability values. So if you divide this coefficient by the standard error, you have the t-statistics. And the rule of decision is that whatever time this t-statistics goes up, the p-value goes down. And when the p-value goes up, the t-statistics goes down. That means that there is a negative relationship between the t-statistics and the probability value. And for you to infer that a particular variable is statistically significant, that means that each of these particular either t-statistics or p-value must actually be looked into. Whenever time the t-statistics is more than 2.3%, that means that there is a significant relationship between the variables, or whenever time the p-value is less than 0.05, that means that the relationship is significant. Aside being significant, the sign of the coefficient or the parameter is also very necessary for interpretation. Whenever time you are seeing a negative sign before the coefficient, that means that the independent variable is having a negative impact on the dependent variable. Or basically, whenever time the independent variable increases by 1%, the dependent variable will only increase by the proportional percentage of the explanatory coefficient. So let's look at it from this angle. From this area, we have the log of market capitalization, and the coefficient is 0.523335. The t-statistics is 2.3, and the p-value is 0.0262. That means that there is a significant relationship or association between the market capitalization and ROGDP, and that whenever time market capitalization increases by 1%, ROGDP increases by 52%. And this particular decreases rather by 52%. This particular assertion is not consistent with the a priori expectation, because the a priori expectation expects that whenever time market capitalization increases, recall what market capitalization means. That means that the level or the rate of growth of the nation's economy will actually increase. And the reason behind this negative concession will be unraveled in our next video. I'm going to give you or teach you how to actually determine the reason behind the behavior of most of the variables. Then the second line we have the value of transaction and its coefficients, the probability values, and the t-statistics. So basically, the value of the transaction in the stock market or in the market is 1.462664. That means that whenever time the value of transaction increases by 1%, it will have 1.46 if impact on the dependent variable, because the p-value is 6.19 and the t-statistics is 6.19 and the probability value is less than 5%. So given the fact that this p-value is above the threshold and is below the threshold and the t-statistics is above the threshold, we now conclude that a long-run relationship exists between the value of transaction in the stock market and ROGDP in Nigeria. That means that an increase in a nation's level of growth is being determined or being driven by the continual increase in the value of transaction in the stock market. And this actually is in line with the prior expectation, because it is expected that when the value of transaction in the stock market increases, economic growth in Nigeria will also increase. Then lastly, we look at the interest rate coefficient. The interest rate coefficient is though positive, which is actually in line with, which is actually inconsistent with the a priori expectation, and it is not statistically significant. Why is it not statistically significant? Because the t-statistics is 1.3, which is less than 2.3, and the p-value is 0.19, which is above 0.5. So we now conclude that this particular variable is not statistically significant and it cannot be validated, it cannot be useful at this point. So while we're looking at the Watson statistics of 0.34, we now see there's an issue that actually need to be addressed. So this is how we actually look at this result, and in my next class I will teach you how to detect spurious regression in OLX results. Thank you for staying tuned to my channel. Thank you for listening. Keep tuned, keep in touch with us. I believe that we are going to expose better information that will be required as time progresses. God bless you and thank you.